Let's take a look at the graph of the cotangent function now, which remember is the reciprocal of the tangent function. So sketching our unit circle quick, this time we're looking at the cotangent from 0 to pi instead of negative pi over 2 to pi, because what happens at 0 radians, cotangent, remember, is cosine over sine. So the cotangent at 0 radians is undefined, that 1 over 0. At pi over 6, what happens with the cotangent? Because it's the reciprocal, the pi over 6 and pi over 3 values flip places. The tangent function at pi over 6 is 0.6, and at pi over 3 it's 1.7. Those flip for the cotangent. So at pi over 6 we have a cotangent 1.7. Pi over 4 is 1. The reciprocal of that, of course, is still 1. And we have a 0.6 at the pi over 3. Up at pi over 2, when we have that 0.01, cosine over sine is 0. And then we have the same values in the second quadrant, they're just negative. So thinking about those reference angles when you flip it over into the second quadrant, and at pi we have it undefined again. So I've got our x-axis scaled for us again to save a little bit of time. So our y-axis we're going to scale up to 2 again. And again, this time I'm just sketching one period of the cotangent function. Similar to the tangent function, it repeats over and over. Similar to all of the trig functions, they're all periodic functions and they all repeat. So we've got those vertical asymptotes at the multiples of pi, and then plotting our points, we've got at pi over 6 about 1.7, coming down to 1 at pi over 4, down to 0.6, and to 0. And the same thing for the next one, down to negative 0.6, negative 1, negative 1.7. So the cotangent function is a snake function as well, but it's a reflection of the snake that we get for the tangent function.